We are going to work on quadratic form. I'm just making this video for those of you that missed this day. So what we're going to do is we're going to try and get expressions in quadratic form. So ay squared plus by plus c, where y is going to be some expression in x. Because we know how to solve, or we know how to factor these types of equations. So x to the fourth plus 12x squared plus 32. So can we think of a way to get this to be in the form of something squared plus something to the first power plus c? Well, how do I get x to the fourth? I can have x squared, so x squared squared. So y would equal then x squared. Does that work out? Well, x squared squared is x to the fourth. If I put a 12 on the outside here, that's 12x squared, and then plus 32. So that works out. So now, instead of factoring this, well, I guess this would just be the quadratic form. That's all this problem is asking for. I'm getting ahead of myself here. So that's the quadratic form. That's what that is. Writing in this form with something squared to the first power, and then you have your c. So looking at this, can we have this be written in the quadratic form in the form ax or ay squared plus by plus c, substituting something in for y? So then we know we're going to have n to the fourth. And what else can we factor out? We can factor out a 5. So then it looks like we're going to have 5n to the fourth, that quantity squared. And then we'll have 5n to the fourth, that's to the first power. And then minus 15, our c always stays the same. But these coefficients are going to change. So 5 squared is 25. 150 divided by 25 is 6. 5 to the first power is 5. So 40 divided by 5 is 8. Like this. And some of you asked, what if we, can we wait to factor that out? Does it have to be in the y? And I think it would work out. The only thing is when we're solving it would work out. The only thing is that we want it to be in quadratic form now. So I'm guessing you could have 150 n to the fourth squared plus 40 n to the fourth minus 15. And then you would factor out the 5, but again, that wouldn't be in quadratic form, so we're just going to stick with this for now. But yeah, just stick with this for now, what you're factoring out. So when we factor and solve, now we're going to take a step further and set it equal to 0. So y does end up equaling x squared, because it's going to be x squared to the second, which is x to the fourth, minus 29 x squared plus 100 equals 0. So let's substitute this y in so it's easier to factor. So the leading coefficient is 1, so we can go ahead and use the Argyle method. So we have negative 29 and 100. What two values, when you multiply them, you get negative 29, and when you add them together, you get, or excuse me, when you multiply them, you get 100, and when you add them together, you get negative 25, negative 29. Sorry, it's the end of the day. My brain is not here. So negative 25 and negative 4, so we have y minus 25, and then y minus 4 equals 0. So y equals 25, and y equals 4. But we don't want to know what y equals, we want to know what x equals, so let's substitute that back in. So we have x squared equals 25, and x squared equals 4. So I square root both sides to get x by itself. The square root, remember, anytime you take the square root, you're going to get plus or minus, so x equals plus or minus 5, and x equals plus or minus 2. And that would be our answer. So the next one is right here, 18x to the fourth minus 21x squared plus 3. So now this is one where you might have some questions. about what can you factor out. Sure, we could go ahead and have y equal 3x squared if you wanted to. I'm just going to try it. I'm going to try x squared. Because they all have a 3 in common, so we could take out a 3x squared if we wanted to. So I'm actually going to do that right now. Never mind. Like I said, it's the end of the day. And if it messes up, I don't have to make a new video. So y equals 3x squared because they all have 3 in common. So let's do this. So 3x squared squared. So that's going to be 9. So 18 divided by 9 is 2. So 3 squared. And then it looks like we have, if we have a 3x squared here, it's going to be a 7 on the outside. And then we have plus 3 equals 0. So in order to factor this, let's plug in y here. So we have 2y squared minus 7y plus 3 equals 0. So this is where we're going to use the t method. So the factors of 2 go here. The factors of 3 go here. And they need to equal a negative 7. So factors of 2 would be 2 and 1. Factors of 3, now they have to be negative because their cross products have to add up to a negative 7. So negative, I think we'd have negative 1 and negative 3. Does that work out? We have a negative 6 here and a negative 1 here. Yep, they add up to a negative 7. So then we go across. So it's 2x minus 1 and 1x minus 3. Excuse me, y. I'm getting ahead of myself. I want to do the x's, but it's y's. So in order to solve this, we set each one equal to 0. So y ends up equaling a positive 1/2 and a positive 3. So we're going to plug in x squared here. X squared equals 1/2 and x squared equals 3. So if I solve for my x's, square both sides. And I'm going to do this one first. X equals plus or minus the square root of 3. So that's 2 answers because we have plus and minus. This one we have x equals plus or minus the square root of 1 over the square root of 2. So what is the square root of 1? It's plus or minus 1. And then we have the square root of 2. And that doesn't work out so well because we have the negative 2 or the square root of 2 on the bottom. So we're going to times by the square root of 2 over the square root of 2. So we end up with x equals plus or minus the square root of 2 over 2. We do that because we can't have the square root in the bottom in the denominator, so we got to multiply by the square root. If you're going to multiply by the square root on the bottom, guess what? You got to do that on the top because we're nice people in math class. So that's all I have for you in this video. Hopefully that helps you out. If you need a little refresher, like I said, we did this in class. Let me know if you have any questions, and we'll talk to you later.